Hi class, so this is part B of section 5.7. So before we get started, I just want to go over something real quick. So we're going to call this composing trigonometric functions and their inverses. Right, so we went over a couple of these formulae, but just so we have all three trig functions, sine, cosine, tangent, and their and what it looks like when we compose with their inverse functions. So we already looked at, if we have sine of inverse sine of x, this is just equal to x, right? So this is the trick though, is x has to be in between -1 and 1, right, in order to do that. And then similarly, if I take inverse sine of sine x, this is equal to x for x in between negative pi over 2 and pi over 2. Right? So then similarly, cosine of inverse cosine of x is equal to x for x in between -1 and 1, right? And then inverse cosine of x is equal to x so remember here we limited x to be in between 0 and pi. And then tangent of inverse tan of x is equal to x so here x could be any real number, right? So x is within the real numbers, right? So this means x is any real number. And then if you do inverse tan of tangent of x, that's going to equal x and in this case, x is in between negative pi over 2 and pi over 2, but not including negative pi over 2 or pi over 2. Right? So you want to be comfortable and familiar with this information. So if we come over here, we're getting ready to start objective 4. So we're going to compose trig functions and their inverse functions. So let's evaluate. What if I have cosine of arc cosine of -1? What's that going to equal? Well, if we're looking over here, this example fits in line with this one, right? So we need x to be between -1 and 1. Well, it is, right? So this is just going to be equal to -1, right? And this is, since -1 is in the interval -1 to 1, right? So the next one is, arc cosine of 4 pi over 3. So we're looking at, this scenario here. So we want x to be within 0 and pi, right? But 4 pi over 3 is not in between 0 and pi, right? So 4 pi over 3 is greater than or equal to 0, but it is not less than or equal to pi. Right, so that's so that doesn't work, right? This is not equal to just 4 pi over 3 then, right? It doesn't work out that way. So what we can do though is we can think of what is cosine of 4 pi over 3, right? What does this equal? And then we can plug it in and keep evaluating this. So 4 pi over 3, right, if I have my unit circle, 4 pi over 3, we would be here, right, where this is pi over 3. So then we want to find cosine of 4 pi over 3. So if I have my triangle, I'm just going to pull this right triangle out, right, where this is pi over 3. This is pi over 6, so we're focusing in on pi over 3. So across from pi over 3 would be radical 3. Across from pi over 6 would be 1. This would be 2. Right, so cosine is adjacent over hypotenuse, right? So this would be 1/2, right? But, you know, don't forget all students take calculus, so this would actually be negative, right? Because we're in the third quadrant. Cosine's negative here. So then, essentially what we have then is cosine, inverse cosine of 4 pi over 3 is equal to inverse cosine of negative 1/2, which is equal to what, right? So, here, on the unit circle, we're limited for cosine between 0 and pi. Right, here's 0, here's pi. And we need to find an angle, that gives me an x value of negative 1/2. So we're going to be here in this quadrant. This point is negative 1/2, comma, and then, whatever that sine value would be, which would be, radical 3 over 2. Oops, and that yellow's a little hard to read. This would be negative 1/2, radical 3 over 2. Right, that would be this point. So then, we're trying to find what this angle would be. Well, this angle we know would be pi over 3, right, from this triangle. So then, what angle would this be? So that would be equal to pi minus pi over 3, which would be 2 pi over 3, right, because this would be 3 pi over 3. So this is equal to 2 pi over 3. That would be the answer that we want here, right? All right. All right, so example 6, we're trying to find the exact value of sine of inverse tangent of 12/5, right? So if we think about this a little bit, this inside part here, let's say theta equal inverse tan of 12/15, right? So this implies, that tangent of theta equals 12/15. Right, we're trying to find sine of theta, essentially, right? So since tangent of theta equals 12/15, right? Remember, tangent of theta is equal to the opposite over the hypotenuse, right? So, for inverse tan, we're going to be in between negative pi over 2 and pi over 2, right? We're stuck in, in this half here. The tangent is positive, so I know I'm going to be in the first quadrant, right? So in other words, my picture, what I have, is I'm going to have this right triangle, and then, so here's theta. Tangent is opposite over hypotenuse, which is equal to 12/15. So the opposite of would be 12. The hypotenuse is 15, and we don't know, it's not opposite over hypotenuse, opposite over adjacent, right? I don't know why I wrote that. So 15, this should be here, right? 15. So we don't know what this is, so we can call this, I don't know, maybe R, right? So, notice how I have this written is since this whole thing is theta, right? What we're really trying to find is sine theta, right? So sine of inverse tan of 12/15 is the same thing as sine theta, right? Because I let theta equal that inside part. So sine theta is going to be equal to, SOHCAHTOA, that'd be opposite over hypotenuse, right? So the opposite here would be 12, and the hypotenuse is r. So I just need to find r and plug that in, right? So we would have, r squared equals 12 squared plus 15 squared. Hope, and that's not 15, that should be 5. Jeez, sorry about that. Just realized that. That was 5, not 15. Right, so then, this would be r squared equals 144 plus 25. So 144 plus 25 is what, 169. So r squared equals 169, which implies that r equals square root of 169, which is 13. Right, of course, I'm only taking the positive part because we're dealing with a distance, right? So r is 13. So we just need to plug in, this would be 12/13, right? Which is the answer we were trying to get. All right, so let's try another one. So example 7, we want to find the exact value of cosine of inverse sine of -2/11, right? So again, something similar, is, let theta equal inverse sine of -2/11. Right, so this implies, that sine of theta equals -2/11, right? Where theta has to be in between -pi/2 and pi/2, right? So we're going to be limited to here. Sine is negative, so we're going to be in the fourth quadrant, right, somewhere down here. Right, so here's my right triangle. I know that sine of theta is equal to opposite over hypotenuse, which is -2/11. So the opposite is going to be -2, so this is -2, and this is 11, the hypotenuse. So this we could say let be x. So if I take -2 squared plus x squared, this is equal to 11 squared. Right, so just using Pythagorean theorem, find the missing side, because what we're trying to find is cosine of inverse sine of -2/11, which is the same thing as cosine of theta, right? Which is equal to adjacent over hypotenuse, which the hypotenuse we already know is 11, so I just need to find adjacent, which we let be x. So I just need to plug that in. So this would give me what? 4 plus x squared equals 121. So continuing up here, we subtract 4 from both sides. We get x squared equals what? 117. So then x would be equal to the square root of 117. Right, it'd be plus minus, but since we're in the fourth quadrant, my x value is going to be positive, right? So I don't need to put that. So this would be equal to radical 117 over 11. That would be the final answer. Right? So example 8, a little different. We have write the expression tangent of inverse sine of x divided by square root of x squared plus 9 as an algebraic expression for x greater than 0. Right? So again, let's let this inside part be theta. Right? So let theta equal inverse sine of x over square root of x squared plus 9. Right? Now something to note is since x is greater than 0, that means that x divided by x squared plus 9, the square root of that, has to also be greater than 0. Right? Oops, I didn't write this very well. So x over radical x squared plus 9 is also greater than 0. Right? So, the way to think about it, if we focus in on the numerator, whoops, I meant to do a highlighter. focus in on the numerator, right? If x is bigger than 0, the top is always going to be positive, right? So this top is positive, right? And then down here, right, if x is always positive, I'm going to take a number, square it, plus 9, take the square root of that. That's always going to be positive, right? So if I take a positive number, divide by a positive number, I'm going to get a positive number, which is just another way, of saying greater than 0. So that's how I can get that statement. So what that tells me, right? So in other words, this would mean that, sine of theta is equal to x. Sine of theta is equal to x over Yes, x over square root of x squared plus 9. Right? So something we know, though, since this sine of theta is always positive, right? So we're stuck, remember for sine, we're stuck between negative pi over 2 and pi over 2. Don't forget all students take calculus, so if it's positive, we're stuck in the first quadrant, right? So in other words, I know theta is acute, right? Or in other words, theta is in between 0 and pi over 2. Right, it's in the first quadrant. So if I draw this, if I draw a triangle with theta, right? So here's theta. Then, sine of theta, that's going to be equal to the opposite over the hypotenuse. So the hypotenuse is the square root of x squared plus 9. The opposite would be x. So we need to figure out what the adjacent side is. So I'll use letter A for adjacent. Right? So then what we could write then, so to solve for A, we would have a squared plus x squared equals x squared plus 9, square root of that, quantity squared. Right? So that gives me a squared plus x squared equals x squared plus 9. So if I subtract x squared from both sides, we get a squared equals 9, which means that a equals the square root of 9, which is 3. Right? I know a is positive because we're stuck in the first quadrant. Right? So then, lastly, what we're trying to find, so we'd have tangent of inverse sine of x over radical x squared plus 9 is equal to tangent of theta, right? Because the inside we let be theta, which would be equal to, that would be the opposite over the adjacent. So that would be x over 3, right? So that's what we're after, x over 3. Right. So then this next one is a word problem, example 9. So it says for the construction of a house, a 16 feet by 6 feet wooden frame is made. Find the angle that the diagonal beam makes with the base of the frame, round to the nearest tenth of a degree. Right. So if you want to draw this, we have this, wooden frame that's made, and then we have the diagonal beams. Right. So this is 16 feet by 6 feet. We want to find this angle theta, right? So in other words, what we have, we can just think about, this right triangle, right? So what we can, this deals with opposite and adjacent, so that's tangent, right? So we could say tangent of theta is equal to 6 over 16, which is 3/8. Right, we can reduce down to 3/8. So then we need to use inverse tangent to find theta, right? So we could say, inverse tangent of 3/8 is equal to theta, which if you put this in your calculator, so if we want it in a degree, right, we need to make sure our mode is in degrees, which mine is not. All right, so now we're in degrees, so I would want to do second tangent of 3/8, and we get roughly 20.6 degrees, right? We're asked to round to the nearest tenth. Right, so there we found theta. Alright, so now the rest of the ones I have are just some mixed practice, just to, help us solve, right? So the first one, number 1, is evaluate sine of inverse sine of 0.4, right? So don't forget, something that we know is that sine of inverse sine of x equals x, where x has to be in between -1 and 1, right? So in this case, we're good, right? We're 0.4 is within the interval -1 to 1, right? So therefore, sine of inverse sine of 0.4, these just cancel each other out, and we're left with just 0.4, right? So then the next one, part B, we kind of have the flip of that, right? So remember, if I have sine inverse sine of sine x, inverse sine of sine x equals x. This is when x is in between -pi/2 and pi/2. Right? So pi/6 is in between -pi/2 and pi/2. Right? So therefore, this is just equal to pi/6. Right? So these are pretty straightforward. Right? They're both inside of there. Right? But don't forget, if we had something like sine of inverse sine of 2.4, this is going to be undefined, right? Because 2.4 is not in between -1 and 1, right? So just as an example of that, we looked at one earlier. All right. So this next one, we have inverse sine of 2π/3. Right? So something you want to note is that 2π/3 is not in between -pi/2 and pi/2 like we would like, right? So this is not equal to just 2π/3. So remember, the trick here is we let this inside part be equal to theta, and then we try to keep working through it and to solve, right? So we say let theta equal sine of 2π/3. Right? So 2π/3, if you want to draw this, where this reference angle is pi/3. Right? So that means, let's see, so this is pi/3, so this would be 1, radical 3, and 2. Right? So sine of 2π/3 is equal to, so this would be the opposite over the adjacent, right? So here's theta right here. So opposite over the hypotenuse, that'd be radical 3/2. Right? So let me just erase this. So this is going to be equal to inverse sine of radical 3/2. So remember, for inverse sine, we're stuck in between -pi/2 and pi/2. So I want to get a y-coordinate, for radical 3/2. So essentially, this triangle here is going to be just flipped over into the first quadrant, right? So this angle is going to be pi/3, which means this is pi/3, right? Because, this would be radical 3, 1, 2, right? So if I evaluate, sine of pi/3, I'm going to get radical 3/2. So this is just equal to pi/3. All right. So the next one, we have inverse tan of square root of 3, right? So let's say, let theta equal inverse tan of radical 3. So what we know is that we want theta to be in between negative pi over 2 and pi over 2. Right, not including negative pi over 2 or pi over 2. Right, because remember we limit the function, right? So essentially what we have is we have tangent of theta equals radical 3. I want to find the angle that makes that work. Right? So the first thing I would be thinking of is drawing a right triangle. And something that has a radical 3 in it is the special triangle with pi over 3 and pi over 6. So this would be radical 3, this would be, 1, and this is 2. So then, remember tangent of theta is equal to the opposite over the adjacent. So if I let theta be pi over 3, whoops, I meant to grab the highlighter again, sorry about that, undo. Right, if I focus in on pi over 3, then we would get, this would become radical 3 over 1, right, which is just radical 3, which is what we're after, right? So, in other words, theta is equal to pi over 3. So what that means is inverse tan of radical 3 is equal to pi over 3. Right? All right. So the next one, we have we have cosine of inverse sine of 1/2. So again, I'm going to let the inside be equal to some value, let's say theta. So let theta equal inverse sine of 1/2, right? Where, of course, theta would have to be in between negative pi over 2 and pi over 2. So this would mean that sine theta is equal to 1/2, right? So when is sine theta equal to 1/2, right? So that's the y value. So if we think about the unit circle, we're going to have, something here where this point is radical 3 over 2. Oops, didn't draw that very well. Radical 3 over 2, comma 1/2. Right, since we're dealing with sine, we're focusing in on the y-coordinate. And this happens when the angle is pi over 6. Right, because remember, we need to be stuck in between these two quadrants, right? Quadrants 1 and 4. So, so theta is equal to pi over 6. Right? So in other words, what we have is cosine of sine negative 1 of 1/2 is equal to cosine of pi over 6, which is going to be equal to the x-coordinate of this point, which is radical 3 over 2. Right? So that's solution there. All right, so I think we have 2 left. So I have tangent of arc sine of 2/3. So again, let's let this inside part be theta. So let theta equal inverse sine of 2/3. So this is equal to tangent of theta, which is equal to. Right, so with this one, I think we're going to have to draw a triangle to figure this one out. So what this implies, right, is that sine of theta equals 2/3, where theta is going to be in between negative pi over 2, pi over 2. Right, so don't forget SOHCAHTOA. So sine of theta is equal to the opposite over hypotenuse. So, so in other words, the 2 is the opposite, and the 3 is going to be the hypotenuse, right, of my right triangle. And I also know that that this is positive, right? So I'm going to be in the first quadrant, right? Because I already know that I'd be stuck in between these two quadrants, but since it's positive, we're going to be here. So here's theta. So the opposite is 2. The hypotenuse is 3. We need to find the adjacent. I'll just let it be a, right? So we would have, a squared plus 2 squared equals 3 squared. So a squared plus 4 equals 9. Subtract 4, we get a squared equals 5. Right, and a here is going to be positive, right? A is going to be greater than 0 because we're in the first quadrant. So if I take the square root of both sides, I get a equals radical 5. Right? So then now I think I'm ready to fill things in. So tangent of theta is going to be equal to the opposite over the adjacent, which the opposite is 2. And we found the adjacent, which was radical 5. So if we want, we could rationalize the denominator. So multiply top and bottom by radical 5. So we get 2 radical 5 over 5. Right, so that's the solution for that one. And then we got one left. So we have tangent of arc sine of x. Right? So again, let's let theta equal arc sine of x. So that means that sine of x is equal to theta, right, where theta is in between negative pi over 2, pi over 2. Right? So, oops. I should have written, hang on, sine of theta equals x. I don't know why I wrote it that way. Right? So then sine of theta is equal to x, which is equal to x over 1, right? If I want to write it kind of like a fraction, right? Which is equal to the opposite over the hypotenuse, right? So if if x is positive or negative, is going to have an influence here. So let's see. So let's assume that x is positive, right? So if x is positive, that means sine's positive. So we're going to be in the first quadrant, right? We're going to have this triangle here, right? Where this, this is theta. So then, opposite would be x, the hypotenuse is 1, and this, adjacent side will let be a. So what we would have is, 1 squared plus x squared, 1 squared equals x squared plus a squared, which would give me 1 equals x squared plus a squared. So we're trying to solve for a, so I subtract x squared from both sides. And what I get is 1 minus x squared equals a squared. So I can take the square root of both sides. Since we're in the first quadrant, a would be positive. So we would have a equals square root of 1 minus x squared. Right, so this is assuming, a bigger than 0 because we're in quadrant 1. Right, because the a value is like the x value, the x coordinate, right? So then, tangent of inverse sine of x would be equal to, tangent of theta, which is equal to the opposite over the adjacent, which is equal to x over a, which is equal to x over square root of 1 minus x squared. Right? Which is what we found, right? So let's see if we get a different value, right? So remember, all of this work was assuming that x was positive, right? What if x is negative, right? What work would we have? So if x is negative, we still have that sine of theta equals, x over 1, right? Which is the opposite over the adjacent. Opposite over hypotenuse. So in this case, since sine's negative, we would be down here in this quadrant. So here's theta. The opposite would be x, hypotenuse would be 1, and here's a. So what we would end up getting, would be the same work, like a squared plus x squared equals 1 squared. So we already did this work, so copied from before, we would still get that a equals the square root of 1 minus x squared, right? So then we would get, tangent of theta equals the opposite over adjacent, which would be equal to x over square root of 1 minus x squared still. Right? So actually we get the same work if x is positive or negative, right? It's just that, when we plug in those values, it would just change the sign potentially of tangent, but it still works out to be the same work, right? So the sign of x didn't actually make a difference for the solution, right? So the solution here is still this part, right? But it's good to double check. Right? All right, so that wraps up this section. So if you have questions, make sure you let me know.